Hello. In this lecture, we will explain some useful functions that are useful for Fourier transform. The first is unit gate function. It is defined as rect of x and it have unit width and unit height centered at origin. Rect of x. Equation for this is rect of x is defined as it is 0 when mod of x is greater than half. It is half when mod of x is equal to half, and it is 1 when mod of x is less than half. Okay? It is 0 when x is greater than half, means these are the values at which rect of x equal to 0. Mod means for negative values as well as for positive values. Similarly, for when mod of x is equal to half, its value is half, means these are the lines at which its value is considered to be half. Similarly, value when it is less than, mod is less than, when it is less than 1, its value is 1. Now we will do a simple exercise, that is expansion. That is, let's say we want to sketch rect of x by tau. So how we will draw it? That is, we will draw it as this expansion factor will be multiplied and it will give us tau by 2 to minus tau by 2. Again it will be centered at origin with height 1. Okay, and this horizontal axis is again x. Clear? So this is rect of x by tau. Next we will discuss second is unit triangular function. Unit triangle function, again it is defined as a triangle function whose height is 1 and whose width is 1, centered at origin, it is defined as del of x 0 when mod of x is greater than half, and 1 minus twice of x when x is less than half. Okay, now again we will do a simple exercise of expansion. Let us sketch del of x by tau. It is del of x. it is triangular function of with respect to x, it is x. So I will draw again this expansion, or that's the parameter tau here, it is divided, so when we draw this, it will be simply multiplied, that is tau by 2 to minus tau by 2 with height 1. Clear? So whenever any function in argument, if it is divided by some parameter in the horizontal axis, it will be multiplied by that argument. Next, we will discuss a very important function. Third useful function is interpolation function. Interpolation function. That is, it is defined as sinc of x, that is sin cx or sinc x. It is an important function in signal processing. It is also known as filtering function. Filtering function. How it is defined? It is defined as sinc of x, sine of x upon x, or it is also defined as sine of pi x upon pi x. How it will be drawn? It is simply continuous function towards x. Here also it is 1, and these are pi, 2 pi and 3 pi and so on. Similarly here it is minus of pi, minus of 2 pi. Okay. Now again let's do a simple exercise of expansion. Let us sketch sinc C of 3 omega 7. How will sketch? For sketching, we need to know from the above function that here it is this function sinc C of x is equal to 0 for x equal to plus minus n pi, that is plus minus pi plus minus 2 of pi plus minus 3 pi and so on. So this whole function sinc of C or sinc function will be 0 for x having values of n pi. Similarly here, because we can see here this sinc function, this is sinc function, it is 0 at n pi's, positive and negative values. Let us sketch. So we need to sketch this sinc of 3 omega 7. So we can draw it. So when this function will be 0, obviously it will be centered at origin. When this will be 0, this will be 0 when, so sinc of C 3 omega 7 C, it is sinc of C will be 0 for 3 omega upon 7 equal to plus minus of n pi, or we can say when omega is equal to plus minus of pi 7 by 3 and continuation of n, that is first will be plus minus 7 pi by 3, second will be 2 into 7 pi by 3, third will be plus minus 3 7 pi by 3, and so on. Okay, so first 0, this indicates that this sinc function will be 0 at these values. So when we draw is first 0, this will be 1, first 0 will be at 7 pi by 3, second 0 will be at 14 pi by 3, third 0 will be at 21 pi by 3. Similarly for negative values, first 0 will be minus 7 pi by 3, second 0 will be at minus 14 pi by 3, and third 0 will be at minus 21 pi by 3, and so on. Okay, so in this lecture we studied very simple and very useful functions that are important in Fourier transform, that are very useful in Fourier transform. Thank you.